Okay. Yeah, so the first question I got here. So first of all, this is for Boyce 130 dosage calc review. And yeah, I always use I use the same basic examples. So if you've already gone through and you feel pretty good about the examples that and you feel pretty confident about it, just know that yeah, I use pretty much the same only because it's not necessarily about different examples, it's more so about that. So okay. Yeah, so okay, so are you Allegheny 130 or yeah, so okay. The material for Boyce is just a little bit different in Allegheny. So yeah, I'll be doing specifically Allegheny 130 at 2 o'clock tomorrow. So if you can't make it, I will record it. But that's I didn't realize you guys had your orientation today at the same time that I was doing your review. So you're welcome. Yeah, sorry for the confusion. All right. So, I did do like kind of like a brief or not a brief, but I did an extra review with some students earlier today. And so I see some of you came back, so welcome back. Those of you that weren't able to be there, just know that you're not missing anything. We're just getting right back into it now. Just so you know, there is no review tomorrow. I had to cancel tomorrow's review session because I have to be in a meeting that I did not know about until either yesterday or 2 days ago. So I apologize for the short notice, but I promise you will be just fine getting through and practicing. So a couple things I highlighted here, just a couple things to pay attention to when you're doing your when you're reviewing for your test next week. Um, um, okay. Darius for Boyce um or for Allegheny? Okay, yeah. There's I mean not me. I will not be doing another voice review tomorrow. So I don't know. Uh, Professor Geyer should have let you know that that Thursday was canceled. So this is all I got for you guys. I'm sorry. Other than if you've been on my YouTube channel, you've already seen this review, so there's plenty of review material out there. And you should have access to my content here. If you don't have access to it, you can email me. I'll put my email in the chat just for those of you who don't see me. Let me just see here. And then you can always get that from me. So if you have any questions while I'm going through the review, please email me. Or I'm sorry, please just type into the chat or you could unmute whatever's convenient for you. And I am recording this and I will upload it onto my YouTube channel as well. So I highlighted a couple things, remembering your metric conversions and also your weight conversions. Remember your conversions from metric to household and more importantly, household to metric. The what's new for you guys this semester is these IV therapy flow rates. You may have seen them in ATI, but you didn't have them on your 110 test. So that's going to be kind of new. So I'll spend some time on those. And then there's some two-step problems that I'll spend some time on as well, which is basically just asking you to do two conversions. Um, so a couple things just to keep in mind, make sure you know what's liquid and what is solid. Um, Remember what solid is things like fruit cocktail, jello, custard. I'm sorry, not jello, fruit cocktail, pudding, custard, chunky soup. That's where the majority of the substance is solid. And so even if it's measured in ounces, those ounces are weight ounces, not liquid ounces. So sometimes they'll try and trick you with that. But most of the other things like popsicles, sorbet, ice cream, even Jello. Those are all considered liquid because they're predominantly liquid, even though you might not think of Jello as a liquid, it's a semi-solid. But if you've ever made Jello, you know that it's majority water and the gelatin mix, which causes it to congeal, and then you make Jello. The other thing to pay attention to is that when we're making, or if they give you ice, whatever ounces of ice they give you, just know that once it melts down to half. So you're just gonna record half. I don't know what specifically you'll see on your test or if anyone's ever had ice listed there, but now you know just in case. And that's your intake question. Make sure you know your conversions. Boy students are usually really good on their conversions, so you guys do a really good job of learning those and memorizing those. So and to just keep in mind, you also have to know the pints and the cups and the quarts and all that kind of stuff. Um, I don't know that you need to worry too much about pounds to ounces or the measurements in length or inches to centimeters, but you might see a conversion like a household to metric conversion where it asks you like, 36 inches, how many centimeters is that? So you do want to make sure you know how to do that conversion. There is, or at least if I remember correctly, there is some discrepancy on the rounding. From what I understand, whenever you go between units, it's okay to round. So if you go from household to metric or metric to household, that it's okay to round, but we don't want to round when we're just doing like a metric to metric conversion. Meaning if I'm going from milligrams to micrograms or milligrams to grams, I don't want to round my answer. I want to give the full answer. All right. So we'll see a couple things. I went over some of these like questions earlier, so and that'll be uploaded on YouTube. I want to kind of focus on the new stuff because I think you should be pretty good for your conversions. Keep in mind that like when we are going from like pounds to kilograms, you are allowed, or at least you should be allowed to round your answer. So rounding to the nearest tenth when you're going from pounds to kilograms. Um, the other thing, and I did this earlier as well, so I'll come back to it if we want to. One of the things a prior student had shared with me, and I agree with, is we basically just convert everything to ounces, add up all the ounces, and then multiply by 30. And that's how we calculate the milliliters for all this stuff. And so we can come back to this if that's something that you wanted to revisit. But I assume you guys all saw this last semester, and so I'm hoping that you're still okay with this. But like I said, we can come back to it. So what I really want to focus on are these flow rate questions. So I went in order last time, but I'm gonna kind of go out of order this time just because we have these extra or actually extra questions, and and some of you may or may not have gone through some of these. But we're going to go ahead and go through them, introducing a couple things. So the first thing I want to introduce is flow rate, right? So flow rate just means we have some sort of volume over a measurement of time. Usually, usually that's ml per hour. Okay. So that's our flow rate. A subcategory of flow rate is drop rate. And drop rate is also volume over time, but the volume this time is drops and the time is minutes. So we have two kind of um, rates that we're going to be working with and learning about this semester and then moving forward throughout the rest of the semesters. And basically, this is what you're going to be potentially plugging into an infusion pump. When do we use ml per hour? We're going to use ml per hour if it ever just asks for the infusion rate and it doesn't give us what's called a drop factor. If we have a drop factor, then we're going to be calculating the drop rate. No drop factor, then no drop rate for the most part. And the reason I say that is because you know from your 110 test is that they're not going to give you the units. You're expected to know what the units of measure are when you're going through and answering these questions. So if you didn't remember that, you're responsible for that. Okay. So when we're doing flow rate, all I need is volume over time. So what I'm going to do here is just talk about flow rate. So the flow rate in this question is 210 milliliters per hour. So there's no math here. It's already answered. Okay. 210 milliliters per hour. That's the flow rate. So if it asks just directly what the flow rate is, that's what we would do. If this said 210 milliliters in 2 hours, then we would do 210 over 2 and we'd get 105 milliliters per hour. But it doesn't say that, so we're not going to worry about doing that. For the drop rate, there's actually a helpful equation for solving for drop rate. You take your flow rate, which like I said before, is usually in ml per hour, but it could also be in ml per minute, and I'll show you examples of that, times your drop factor, and your drop factor is going to be in drops per ml. So those are going to be given to you, or the drop factor will be given to you. If it's not given to you, like let's say they use microtubing, I don't think they're going to do this to you, but if they use microtubing, that is 60 drops per milliliter. So that's a standard thing. All right. When we put those two pieces together, that'll give us our drop rate, and our drop rate is drops per minute. So let's solve for this equation here. So what I have here is 210 ml per hour. So that's my flow rate times my drop factor, which is 10. Now, the other thing is, remember, our drop rate is going to be in per minute. So I also need to convert hours to minutes. So 1 hour, 60 minutes. Once I've done that, we can now check to see milliliters are gone, hour is gone, and then what we have left is drops per minute. So before I do any math, I know that I'm in the right units that I want to be in. So I'm going to take 210 times 10 and then divide by 60. And then I get 35 drops per minute. Now, I want to show you another shorthand way because you're going to get aggravated by adding all these extra dimensional analysis things, especially those of you who hate dimensional analysis. So another way I can write this is I can take my 210 ml, and I know that 1 hour is 60 minutes times my drop factor, and we can see that we save a step here, and I get the same answer, 35. So hopefully that's helpful. Um, so I want to find another question. Oh, the other thing I forgot to mention. So you'll notice that even though it mentions 500 milliliters of the dextrose 5% water, we don't use that 500 milliliters. We don't need that information. We only need the flow rate and the drop factor. The only reason I would need to know the total volume of the IV is if it gave me that 500 milliliters and said it was infusing over 2 hours, then I would need to know that. And that's what I'm going to show you next. I think there's going to be another example similar to that. So give me a second here. Let's go to let's look at this gentamicin question. So this question says to administer gentamicin 75 milligrams in 150 milliliters dextrose 5% water over 35 minutes every 6 hours. So there's a lot of numbers there. And there's a drop factor of 5. And it says, what is the flow rate? So if it gives you the drop factor, right, that's your indication that we're going to be calculating for drops per minute. Even when it says, what is the flow rate? Because that might be exactly how it's written for you on your test. It might say what is the flow rate in drops per minute. I don't know, but I just wanted to prepare you just in case that's how that's asked. So, how do I calculate the flow rate? Or how do I calculate the drop rate? Well, I get the flow rate. So I take my volume, right? So my 150 ml over my time, 35 minutes. And I'm going to tell you right now, if you're looking for drops per minute and it's already in minutes, don't, don't, don't convert it to hours. Okay. Then I'm going to multiply by my drop factor and then cancel out mLs, and then we'll get our drop rate. Now, before I solve it, I just wanted to mention a couple things. Why didn't I include the 6 hours? Well, what this protocol is saying is that we're going to give this patient this medication. We're going to infuse it over 35 minutes. After 35 minutes, we're done with the infusion and we're going to repeat it 6 hours later. So this is very different than just like swallowing a pill or getting a bolus dose or something, or even just having a constant IV drip. This is a specific application of a medication over that 35-minute time period, and that's what's going to constitute the flow rate. This every 6 hours just tells you to repeat it, which is why we ignore it. The other thing is when we're doing drop rate or flow rate, we don't care about the strength of the medication. It's important to know, obviously, to make sure for safety procedures that you're giving the patient the correct medication, but we don't need to know from the standpoint of, um, for calculating the actual rate. The rate is just the speed. We only care about the speed. For the math part, we don't care about what it is. Obviously, from the nursing perspective and when you're working with the patient, you absolutely 100% care what it is, but you also need to care about how you get to the conclusion of calculating it. They might also only indicate drop factor, which is why I keep writing the units just so you remember that it's drops per milliliter. Okay. So I'm going to plug into my calculator 150 times 5 and divided by 35. Now I'm going to get a weird number here. Weird because it's not an even number, but I'm going to get 21.42857. So I cannot give somebody a partial drop. So what I have to do is I have to look at the decimal and decide what I'm going to do with the whole number. So if it's 4 or fewer, then we drop it, and then my final answer would be 21 drops per minute. If this had been 21.5 or 21.6, then you could round it up to 22 drops per minute. But we can't give somebody a partial drop. So just letting you know that in case you're like, but I want to give them a partial drop. You can't. It either gives it a drop or it doesn't. Drops or it doesn't. And then this is just another variation. These questions here, I'm just kind of giving different variations of the same types of question. So I like to leave these open just so you can practice them, or you can look over because I went over a couple of these as well. What if it's just a standard infusion rate? Like they just want to know what the infusion rate is. So a couple clues that's all you're doing is you'll notice that this says 400 milliliters of Ringer's lactate over 5 hours, and then it doesn't say anything about a drop factor. No drop factor listed. They're looking for ml per hour. So all you're going to do is take 400 milliliters over 5 hours. You're going to do 400 divided by 5, and you're going to get 80 milliliters per hour. And then you would do the same thing for this, but instead of 5 hours, it's 1.5 hours. Sometimes it might ask you to calculate how long something is running for. So I think I went over this earlier today as well. But what they're saying is you have a 250 milliliter IV. It's running at 100 milliliters per hour. And they want to know how long in hours and minutes will that be running for. So you're going to take your 250 ml and then you're going to multiply by your infusion rate. But what we're going to do is we want to get rid of milliliters and find out how many hours. So 100 milliliters. And when we do that, I get 2.5 hours, which is, if it's asking for hours and minutes, you just say 2 hours, 30 minutes. I don't know that you'll get a question like this. I just wanted to make sure, just in case something like this gets asked, that you've at least seen it. Just so you know. All right. I didn't go over these before, but I wanted to do the insure questions real quick, or one of them. So one of the things that sometimes can trip students up is the 40 minutes, knowing that you're calculating milliliters per hour. So you're still going to set this up the same way. You're going to take 240 ml. You're still going to put it over the 40 minutes, but this time you're going to convert minutes to hours. So I always start with what I'm trying to get rid of or what I'm wanting to leave, right? Because I want ml per hour. And you know that 60 minutes is 1 hour. One of the main reasons why I'm an advocate for dimensional analysis is because I've worked with enough nursing students over the years to know that some of you will multiply when you meant to divide, or will divide when you meant to multiply. Writing this out, believe it or not, helps to organize the material, and you're less likely to do that. I don't want to say it's foolproof, but you're less likely to do that. Okay. So I'm going to take 240 times 60 and then divided by 40, and I'm going to get 360 milliliters per hour. And you might be saying, wait a second, they're only supposed to get 240. How am I giving them 360? Well, they're going to run out of it before they hit 40, right? Before it hits an hour, they will have already gone through the 240 milliliters. So it's just about the pace in which it's going through. Okay, so don't get hung up. It's kind of like if you're only going, 10 miles, but you're traveling at 100 miles per hour. It's not like you it just means you're going faster than like you're supposed to be going, right? At 40 miles an hour or 55 or whatever it is. All right. These are the two-step problems. I worked through this one earlier today, so let me go ahead and do this one now. That way we have two variations that we can kind of see. Um, so in this, why this is two steps is because you have a patient's weight in pounds, but we have a weight-based medicine. So we need to actually convert the patient's weight in pounds to kilograms, and then we need to convert then the milligrams that we get from that into the milliliters of the medication, the ibuprofen that we're trying to do. So I'm going to show you, this is something like, just as an aside, when you're converting your pounds to kilograms, so let's say you take 73 and you divide it by the 2.2, this is not going to be an even number. So 73 divided by 2.2, and it's 33.18 repeating. Okay. Now, typically, 0.18 repeating, we could round that to 33.2 kilograms, and we should be okay. The problem is, and you'll learn this in third semester, is that when we're dealing with like pediatrics, we want to be very, very careful about our rounding, because if we round up and it's for a real little kid, that might not be the appropriate way to administer that medication. And so there are like safe dose ranges for based on a child's age as well as the child's weight. So there's a couple things to kind of factor in and consider. Saying all that, what I would recommend doing is setting up, again, you're going to hate it with the dimensional analysis, but setting it up all the way and then doing your rounding at the very end. And then I'll show you, it probably will work out where it's basically the same anyways, but just so you're not rounding twice. So what I'm going to do is I'm going to take my 73-pound patient and I'm going to convert the pounds to kilograms. And 1 kilogram is 2.2 pounds. Sorry. Already had the LB listed there. Then once I am out of pounds and into kilograms, now I can multiply by my order, which is the 3 milligrams per kilogram. So again, this is a weight-based calculation. So at this point, I'm in milligrams, but what I'm looking for is milliliters. How do I know I'm looking for milliliters? Just in case it doesn't ask you, because it might just ask you how much medication will you give the patient. If the medication is listed with milliliters, that's what you're going to administer, right? You should already know that you don't give them milligrams. You can't give them milligrams. You can't give them um, micrograms. You give them milliliters, or you give them a capsule, or you give them cc's, or you give them a tablet. They're gonna get some sort of the way that it's packaged. That's how you're gonna give it to them. So if you see milliliters, that's what you give. If this said capsules, then that's what you would do. You would say 50 milligrams per 2 capsule or whatever it happens to be. So this says 2 ml. So the next thing we're going to do is we're going to convert milligrams. Hey, when it does that, we're going to convert milligrams to milliliters using our available. So 50 milligrams is our available dose, and our quantity is 2. Milligrams are gone, and we're left with our ml, which is what we're looking for. So I take my 73 times 3 times 2 equals divided by 2.2 and divided by 50. And I get a final answer of, oh, maybe I did do this one earlier. Well, unless it happened to be the same answer somehow. 3.98 milliliters. Now, when you see that it's 3.98 and you're doing your rounding and it's the next number up is 9, and it's going to round up, this is 4 milliliters. Okay, so it is the whole number. When you're at 3.98, you're at 4 milliliters. Just so you know, that you're not the 0.02 milliliter difference shouldn't be a problem. But you could always confirm with your instructor if you're concerned about your rounding rules. I guess I should also mention for rounding rules, just remember if you have something greater than 1 milliliter, you're going to round to the 10th place. And if it's less than 1 milliliter, you're going to round to the thousandth. I'm sorry, that's supposed to be hundredths. This is the thousandth place. Meaning, if you have like 1.275 milliliters, you look at the 75, you're going to round that up to 1.3. And if you had 0.275 milliliters, you're going to look at the 5. And then if it's 5 or greater, you would round that up. And so your answer would be 0.28 milliliters. So just something to kind of keep in mind there. All right. Let's see here. I think your guys are okay with insulin. I did this one, so let me go to the next one here. So you probably already saw, I'm pretty sure you saw the reconstitution question last semester. I don't think this is the same one you had, but it's similar. Um, so when you're doing your reconstitution, first of all, there's a couple pieces of information to let you know you're dealing with a reconstitution. The first thing is when you see 500 milligrams, you're usually looking for 500 milligrams per tablet or capsule. That's really the only time you see 500 milligrams by itself. Usually, when you see something that's a suspension, it'll say like 250 milligrams per 5 ml or 125 milligrams per milliliter. You'll see something that indicates how many milliliters or how many milligrams per milliliter. The other clue is, and that you're dealing with a reconstitution other than it's sometimes saying the word, if it's intramuscular. If If it's intramuscular, you know that you are administering ml. How do you know that? Well, because it's an injectable, right? You can't force a tablet into the muscle, right? So we're going to inject liquid, and liquid's going to be measured in milliliters. So when you see just that strength there, that 500 milligrams, and you know you're looking for milliliters, that's your clue that you need to look at the label off to the side here. Okay. And what you're looking for is you want to read through the directions, and it'll tell you some things like it says the usual dosage range, the timing, and then it starts to tell you how to prepare it. It'll say for IM administration, which is what we're doing. You're adding 2 milliliters of water. It's not really what you're looking for. What you're looking for is the approximate total volume. And what you're really looking for is where they tell you in parentheses the exact concentration after the pharmacy has added the liquid or after you have added the sterile water to it. So that number, the 225 milligrams per milliliter, that's what you're looking for. That's the available that you want to use. So you have 0.375 grams, which is the same thing as 375 milligrams. And then I'm going to convert milligrams to milliliters. 225 milligrams, 1 milliliter. I always forget the answer to this one, but 375 divided by 225, and we get 1.6 repeating. So again, when we have something that's doing that, that's your clue that we need to round. In this instance, we're going to round to the nearest tenth. Don't round it to 2 milliliters. Your rounding rules per your blueprint tell you to round it to the nearest tenth, not to the nearest whole number, at least for these types of questions.
So, Dr. Red, I have a
Yeah,
question.
go
So,
ahead.
most of the time, is it always in parentheses, or it's just these two paired together? It would be like ml, mg, milligrams, and ml. So, it'd be with the slash, or it's always in parentheses.
So I typically, at least the few examples that I can think of, is that it's usually in the parentheses. It's usually right after it tells you what the approximate total volume is, and then it puts it in parentheses. So that's where I've seen it traditionally.
Okay, all right, thank you.
You're welcome. Good question. Um, all right, so I kind of went over the majority of these questions. If you've watched any of my prior YouTube videos, and you've probably seen that I've gone through a number of these already. So it's like I'm just repeating myself. But if there's another question type that you're struggling with, or something else you want to see, or something you want to go back to, this is a perfect time to ask. And like I said, you can unmute, you can type in the chat.
Hey, I'm sorry I came late. Would you mind doing another minutes per drop per minute question?
Sure. Thank you for your question. All right, so
Yeah.
let's. I have another one up here, so let's get to it. Uh, flow rate. Okay, so let's do this. We'll do this other. Let's do the 30 milligram gentamicin. Okay, so this is just like the other one that we did, and then just as a reminder, in order to calculate, remember, it might just say what is the flow rate, right? And so you need to know, is it ml per hour that they're looking for, or are they looking for drops per minute? So the next thing that kind of gives you a clue what you're looking for is they'll tell you the drop factor. Okay. So if they tell you the drop factor, that's your clue that you're looking for drops per minute. Okay. So in order to calculate this, I need to know two pieces of information. I need to know the flow rate, and I need to know the drop factor. And then I just need to make sure that it's in minutes instead of hours. So my flow rate is, it says 250 ml, and then it says 2 hours. But instead of 2 hours, I'm going to write 120 minutes, because 60 times 2 is 120. And because I'm looking for drops per minute, I might as well just go ahead and keep it there. My drop factor Remember, you might need to know that it's 15 drops per ml, but as long as you know just to convert to hours to minutes and then multiply by the drop factor, you should be fine. But if you like to do it dimensional analysis wise, again, you can see that we're in the right units before we do any kind of math. So I'm going to take 250 times 15 and divide it by 120. Now I'm going to get 31.25 drops per minute. So I'm glad that I had this here, because one of the things, we cannot give somebody a partial drop, right? So I have to drop that. I either need to round up or just drop it. And so since this is at 31.25, we're going to round that to just 31 drops per minute. That would be your final answer. Make sure when you're writing out your drops per minute, that that it's a whole number as your final answer.
Thank you.
You're welcome. Good question. All right. Any other questions? I know I went through this a little bit quickly. Go ahead, Edith.
Yes, please, Dr. Hart, if it's to write GT, like to say drop, if I write the whole thing like drop per minute, are they going to cancel it?
Oh, I don't think so. I think it's fine if you say drop, um, versus GTT. I know the standard though is GTT, so I don't know that definitively. I mean, if you write drop per minute, what you don't want to write is DR per minute. DR is a different unit. It stands for drams. You definitely don't want to do that, and they'll mark that wrong because you're using the wrong unit. So, but if you write drops, it should be okay. But I would ask your lab instructor or Professor Geyer and just ask them first.
Okay, thank you.
You're welcome. It's a good question. And if any of you like hopped on a little bit late, I am recording this. If you missed any of it, I will have it up on my YouTube channel this evening, including the one that I did earlier today, so that way you have access to it. I'll also say that if you are working through these and you have some questions come up like throughout the rest of the week, feel free to email me. I put my email into the chat. Professor Geyer also has my email. You can email me and let me know what works best for you, or what your question is, and I'll be happy to answer it. I usually will come back with, what did you do? Like, how did you try to solve it? So let me know what you tried so I can see the work you've done. And then and if you don't have any other questions, just know that I'm hoping that you do really well. I'll be very surprised if you don't, because you should be very well prepared. But just know that I'm here for you if you have any questions. And like I said, I'm going to stick around for the next 10 minutes. So if you have anything come up while you're reviewing, just drop it in the chat or unmute.
I do have one other question. So your YouTube channel, is it just under your name, and it'll be there like indefinitely, or just for like a few hours after this?
It'll be there. I've kept them there over the years, so they're there. Anytime I've ever done a review, it's on there.
Okay.
And I've just left it there. So I usually leave it indefinitely. And then you can, yeah, if you type in Dr. Rad, the Rad tutor, or it should have been in the PDF that Professor Geyer emailed out. It should say there should have been a link in the PDF showing
Okay.
how to get to my information. But you can also email me, Tanya, and I can forward you the link.
Okay. All right. Thank you.
You're welcome.
Also have a quick question, please. Can we
Okay.
do the previous exercise that you said that we should do at the end? It was about, I think, the intake.
Oh, okay. Thank
Thank
you.
you.
You talking about this one here?
Yes, I think so.
Okay. Yeah, let's do it. All right. So a couple things. So remember, it's your responsibility to know what is considered liquid and what is considered solid. Sometimes it's very obvious, right? Like this turkey sandwich is solid, so we're not worrying about it. But where it gets a little bit like dicey is fruit cocktail, custard, pudding. Those all seem like they're liquids, but they're actually solids. Whereas ice cream seems like it could be solid, and a popsicle can seem like it's solid, but it's actually liquid. So basically it's saying like what is it state at room temperature? And you'd be like, but Jello is solid at room temperature. And you're right, but when you're making Jello, it's predominantly liquid. Okay. So that's where it gets a little bit tricky. I think they try and trick you more in ATI than they will on the actual dosage calc test. But just so you know, they'll also sometimes will give you like a little tidbit. They'll tell you that a glass holds 8 ounces, right? Because you can't just assume all glasses are 8 ounces. I think about it at my house, I have glasses that hold 16, 12, 10. Like there's a variety of different things. Yeah. Yeah, so good analysis there, and at least saying anything that can melt or is made from just liquid. So it just says a half glass of orange juice, so that is 4 ounces. Then we have 10 ounces of coffee, one turkey sandwich. Don't need to worry about that. I have 2.5 ounces of Jello, a half pint. So what's a half pint? So remember, 1 pint is 2 cups. So a half pint would be 1 cup. So 1 cup, which is 8 ounces. A half quart. So remember, 1 quart is 2 pints. So if it's a half quart, then that's 1 pint, which is 2 cups, which is 16 ounces. So what I mentioned earlier that another Boyce student had done this, and I liked it, is basically all we're going to do is we're going to add all these up, all these ounces. So I'm going to do 4 plus 10 plus 2.5 plus 8 plus 16. So I'm going to add these together, and I'm going to get. So I'm going to walk through it with you. 4 plus 10 plus 2.5 plus 8 plus 16. So I'm going to get 40.5 ounces. I'm going to take that 40.5 ounces and I'm going to convert it to milliliters. So I just need to multiply by 30 milliliters, right? Because 1 ounce is equal to 30 milliliters. 40.5 times 30, and then I get 1,215 milliliters. That's the other thing. They're just going to tell you calculate the total fluid intake. You need to know that you're looking for milliliters because they're not going to tell you that, but now you know. I mean, you should have known last semester, but that's okay. So I wouldn't say 1.215 liters, although technically you're saying the same thing. They specifically are asking for milliliters. I don't think you're going to have a big, like over 1,000 milliliters answer, but um, hopefully you find that this is helpful, just converting everything to ounces. And you can see, like, because you probably already have it memorized that 1 cup is 8 ounces and 1 pint is 2 cups, which is 16 ounces. Like you may already have that memorized. And if you didn't, then hopefully what I put together made sense. And I hope that was helpful.
Thank you.
You're welcome. Great question.
Dr. Rad, are there any printable documents that we can have these exact problems on?
Yes, the PDF, you should have got I did send a PDF to Professor Geyer and there should have been links in the PDF. So I don't know how that got administered to you guys, But if you email me, I'll email you a copy of the PDF, and then you can just click on. I have a shared Google Drive folder that has a whole bunch of materials for Boyce, for Allegheny, for North, and then you can have them to utilize.
Okay, perfect. Your email is that, let me see if I have it saved. I'm sorry.
That's okay. Here, I'm gonna put it in the chat.
Okay.
There you go.
Thank you so much.
You're welcome. All right. Are there any other questions?
No, I don't have any. Thank you.
Okay. No, you're welcome, Tanya. Yeah, if there's no other questions, like I said, if something comes up later on, email me. I don't care what time you email me, just don't expect me to reply right away. But give me a couple like 24 hours to respond. So don't email me, Sunday at 2 a.m. and think I'm gonna get back to you before your test on Monday or whenever your test is. Give me some time. I do have I have some office hours that I'll be available in the morning, so I'll be checking the email and things like that Monday morning. But if you have a question, just shoot me an email. And then you can also go back and look at the other 130 review sessions because sometimes I may have covered a little bit more, a little bit less. It just depends. I try and go with whatever students want. So. But if you don't have any other questions, I wish you the best of luck. Good luck with this semester. Oh, go ahead.
No, thank you.
Oh, you're welcome.
Thank you.
You're welcome. Yeah, thanks for coming. I appreciate your attendance. And hopefully this was helpful.
It was. Thank you.
Okay, good.